Dear students, in last class we have completed impulse invariant transformation. Today we will start bilinear transformation. Bilinear transformation transforms the imaginary axis of S plane into the unit circle in the Z plane. Only once. It means that if here we have S plane with real axis and imaginary axis as shown, then bilinear transformation will map this or transform this imaginary axis into a unit circle in the Z plane. That means this axis is transformed to unit circle. Z plane real axis is here and imaginary axis is here. Radius of this circle is equal to unity, that is 1. And here, when imaginary axis is transformed to a unit circle, there will be only one circle, no multiple circles or no concentric circles, which avoids aliasing effect. If multiple circles are there, then there will be aliasing effect. Thus, avoiding aliasing of frequency components. In this method, all points in the left half of S plane are mapped inside the unit circle in the Z plane. The Z plane, and all points in the right half of S plane are mapped outside the unit circle in the Z plane. That is, if we have any pole here, P1, P2, P3 and so on, these all poles will be found inside this unit circle. And if there are any poles on the right hand side of S plane, so we are having here capital P1, capital P2, capital P3, these are all small p's which denote poles on the left hand side of S plane. Capital P's which are on the right hand side of S plane will be mapped outside the circle this way. Which means that stable analog filter in analog domain will be transformed to stable digital filter by bilinear transformation, because we know that the poles on the left hand side of the S plane contribute for stability. The bilinear transformation can be linked to the trapezoidal formula for numerical integration. Any analog system is governed by a differential equation. In time domain, Consider the first order differential equation of an analog system as given below. Let dy of t by dt is equal to x of t. Let us call this as equation 1. On integrating both sides of equation 1, we get here we are going for numerical integration. So dy of t by dt integration over the limits n minus 1 into t to n into t dt equal to integration of x of t dt. Limits of integration are once again n minus 1 into t to n into t. That means we are having here certain function say x of t which varies with time. I am integrating it between two samples. If it is my nth sample, then it will be n minus 1th sample. In discrete time domain, it is n minus 1 into t and it is n into capital T. So limits of integration are n minus 1 into t to n into t. I am integrating the part of function x of t between n minus 1 into t to n into t. But what is integration of d into y of t by dt into dt? It will be simply y of t. And limits of integration are n minus 1 into t to n into t equal to n minus 1 into t equal to integration of x of t with respect to t with limits of integration from n minus 1 into t to n into t. Substituting for the limits of integration, we get y of nt minus y of n minus 1 into t equal to integration of x of t with respect to t n minus 1 into t, and n into t are the limits of integration. Let us call this as equation 2. Integration means what? Integration of this function x of t is nothing but finding the area under the curve with given time limits. That is this area we have to find. And this area appears to us like a trapezium. Therefore, the integration of x of t here would be now written as area of a trapezium. The integral on the right side of equation 2 can be approximated by the trapezoidal rule. So that y of nt minus y of n minus 1 into t is equal to x of, how do you calculate area of trapezium? Area of trapezium is sum of parallel sides. If it is A and this is B, A plus B, into the distance between parallel sides. Say this is what? Height of the trapezium, into half. That is, area of trapezium is half into h into A plus B. But here what is the value of A? The value of A here is value of x of t at t equal to n minus 1 into t. And what is the value of B? Value of B is x of t at t equal to n into t. So here we will have B, and that is equal to x of n into capital T. And what we will have here? A. What is A? A is x of n minus 1 into T. So x of n into T plus x of n minus 1 into T into h. What is h here then? H is n into T minus n minus 1 into T divided by 2 will give us area of trapezium. So now we will write integration of x of t with limits n minus 1 into t to nt as x of nt plus x of n minus 1 into t into nt minus n minus 1 into t whole divided by 2. On simplification we get nt minus nt plus t. Nt minus nt will cancel, we will get finally capital T. So you can write here t by 2 into the bracket x of nt plus x of n minus 1 into t, and our RHS and our LHS remains same, y of nt minus y of n minus 1 into t I will number this as equation 3 now. For discrete time systems, the equation 3 can be written as y of n minus y of n minus 1 t by 2 into the bracket x of n plus x of n minus 1. Taking Z transform, of equation, let us call this as equation 4 here, of equation 4 we get Z transform of y of n is y of z, Z transform of y of n minus 1 is z raised to minus 1 into y of z, t by 2 into the bracket x of z plus z raised to minus 1 into x of z. Taking common outside y of z on LHS and x of z on RHS, we get y of z inside the bracket 1 minus z raised to minus 1 equal to t by 2 into x of z inside the bracket 1 plus z raised to minus 1. Writing for x of z, we get 2 by t into 1 minus z raised to minus 1 upon 1 plus z raised to minus 1 into y of z. Let us call this as equation 5. On taking Laplace transform of equation one, we get s into y of s equal to x of s. On comparing equations five and 6, let us call this as equation 6 here. We get s into y of s transformation as 2 by t into the bracket 1 minus z raised to minus 1 upon 1 plus z raised to minus 1. This is by what? BLT transformation. Where capital T is sampling time period. Hence, in the S domain transfer function, if S is replaced by, or if S is substituted by the term two by t 1 minus z raised to minus 1 upon 1 plus z raised to minus 1 the resulting transfer function will be z domain transfer function.